Okay, everybody. Well, this is it. Just got a couple problems I want to go over with you. I just the ones that were really bad. Some of them really surprised me. The first one that was bad on here was number one, the speed of light, and that's the frequency, of course. That's so it matches what's on the reference table. Okay. In corn oil is, well, you just look up the index in corn oil. There's my index, 1.47. N equals C over V, or V equals C over N. There's speed of light in a vacuum. There's your index. And there's your velocity in the corn oil, 2.04 times 10 to the 8th. Relatively easy. Now the next part, what wavelength is in the infrared range of the electromagnetic spectrum? Okay. Well, infrared runs from about 1 times 10 to the 6th, a little higher than that, it's a little closer to 2 times 10 to the negative 6th. I mean, it's a little bit bigger than that, but not, a little bit shorter than that, forgive me. And then it runs to about 1 times 10 to the 3rd. But if you say 1 times 10 to the negative 6th to 1 times 10 to the negative 3rd, that'd be fine. Okay, so 100 nanometers, that's 100 times 10 to the negative 7th, 1 times 10 to the negative 7th. Sorry, that's actually in this range. So that's right around ultraviolet. 100 meters, that's all 10 to the 2nd. That's radio waves and stuff like that. 100 millimeters, that's 100 times 10 to the negative 3rd, or 1 times 10 to the negative 1st. That's pretty much in the microwave and radio wave area right there. And finally, 100 micrometers, micros 10 to the negative 6th, 100 times 10 to the negative 6th, or 1 times 10 to the negative 4th. Bingo. Right inside the infrared range. Okay, next one that was a little bad was this guy right here. I've written all over it, but it was 17. The easiest thing to do is draw a normal right down there. You know between the normal and the surface is 90 degrees. If that's 65, then this has got to be 25. That's my angle of incidence. That means, of course, my angle of reflection is also going to be 25 degrees. Actually, a pretty easy and very common question. Okay, next one after that was, okay. Let's take a quick look at my numbers here. Next one after that is going to be 26. 26. The diagram shows a light ray air incident on a crown glass block. So it's air going to crown glass. I drew it. It should be doing the following. Since air's n equals 1, the crown glass is 1.52. The light is going to slow down going into the glass block. And when it slows down, it bends towards the normal. If it speeds up, it would bend away from the normal. So it's going to slow down and bend towards the normal. I added that little diagram in there. All right. Next one was 33. It says the diagram below shows a ray of light passing from medium X into air. And they want to find out what the index is for medium X. Well, Snell's law, N1 sine theta 1 equals N2 sine theta 2. All right, so we're going to call this theta 1, this theta 2. So you don't know what the N is, but you know it's at 30 degrees. You know the air is 1 times the sine of 60. Do the math, you get an index of 1.73. And the very last one, people, is right here. Base your answers on the following. You got this ray diagram going here. They told you this was 45 degrees up here, and you want to find out what the sine of theta 2 is. Oh, I went too far here. I actually figured out theta 2. I'll take the sine of it. Okay. We'll fix that in a second. All right, so it's N1 sine theta 1 equals N2 sine theta 2. 1 times the 45 equals 1.5 times the sine of theta 2. So that means that my sine of theta 2 is going to turn out to be about 0.47. 0.471, actually. Now, if you arc sine it, you get 28 degrees, but we really don't need that. We just needed this. And that's it, people. I'm going to post this, the answers to the to the drawings that you guys did for Monday. And don't forget, Friday, we're going to have just a very, very quick Zoom meeting just to kind of, end the year off and everything off as well as we can. All right, everybody be safe, take care, and I wish you all well. Bye-bye now.